And hello, everyone, and welcome to a Chaos Mode edition of Learn with Jason. Today on the show, we have Finite Singularity Mark Dobossy. Thank you so much, Mark, for being here.
You're very welcome. I'm glad to be here.
So I am. Everybody, please let me know how the audio, everything like that is coming through, because we're trying something fun today. We are going to attempt to make different filters and effects within OBS, which means that I am actually on a PC instead of a Mac today. So I'm on a different set of a different instance of OBS. We're going to be running a second instance of OBS. I had to set up all my audio and everything differently. So if things are weird, not functioning as expected, please do let me know, because we're making this up as we go along. So Mark, before we start getting into all that, can you give us just a little bit of a background on yourself, who you are, what you do?
Yeah, so I'm actually one of these folks who had a really atypical journey into this whole software dev tech thing. I hold a PhD in structural engineering, of all things, and did a whole lot of work on high performance computing. We called it back then Beowulf clusters. Had a lot of fun names for things, which I guess is just now like cloud computing today. But we did a whole lot of like distributed computing kind of things, and it was a learning journey, and came out of my graduate work, did a postdoc in a couple things, started up a little sort of environmental engineering company that lasted for several years, simulating subsurface fluid flow stuff. It was kind of fun programming problems. I did my obligatory stint in fintech, and suffered through that for a few years. And the happiest day of my life was when I jumped out of fintech and started what I'm currently doing, which is a big giant construction field logistics mobile app, of all things. So I've kind of jumped around a lot. A few years ago, I tuned in a lot to Michael Jolly, Bald Bearded Builder's
Oh
stream,
yeah.
and he had encouraged me to start streaming, and I'm so glad he did, because it really is one of the highlights of my week. Every time I can flip on that stream button and kind of co-work with people and share with people what we're doing. And one of the big things I like to do on stream is interactions with chat. So building
Yeah.
things physical and software based, where chat can affect the stream and change things on the stream. And it's a blast. It's an absolute blast.
That's so much fun. I have seen a little bit of your stream, and I have really enjoyed just how creative you've actually been with all of that, because I've done a little bit with interactivity. I've had a couple fun games and stuff, but they've all been pretty limited in what they are. You make something kind of appear on the screen, but it's a looped GIF, right? Or for a while there was, you were capable of, if you used the boop emoji in chat, it would drop and fill the screen, and that has. I'm looking at ways to bring that back. Probably not for the episodes like these, but for the Tuesday streams when things can be a little more chaotic.
Absolutely. I will warn you up front, it is a rabbit hole. And when you start going down the rabbit hole, sometimes you don't like pop your head up for air for quite a while, because it can be a lot of fun. It can be a lot of fun. There's something about being developers, I think, where software development in and of itself is a creative kind of a work or a task, but we don't think about it that way a lot. And one of the things I love about what I do on the stream and the things that we build is it lets me kind of flex those more specifically creative parts of my brain and work those out a bit, which I think is really, really valuable as a software developer.
Yeah, I think a huge portion of what makes me feel good about doing this job is the playfulness of it, right? Like I think you can find a way to be playful in any discipline, but I feel that the web is uniquely suited to being playful, right? It's such an inherently human
Absolutely.
medium. It's such an inherently
Mhm.
connected medium, and so it's no matter how you get onto the web, whether it's through websites or through streaming software or any of those things, there's this amazing opportunity to be playful and to be playful in a group, like in a community.
Yeah.
And that's actually what originally kind of made me aware of your work, was that it felt very much like we were maybe kindred spirits in that way, in terms of just, you've got so much playful stuff going on your stream. And what really piqued my interest is you were doing things that I thought were impossible. And so
and they were things that I probably thought were impossible a day before, right? I get these ideas and I go, I don't know if I can do that. And that just makes me want to do it more. So then I start to research, how might we do this? And then shaders hit you in the face and then it's all over. So
yeah. Well, and speaking of the community, thank you so much, Ishan, for the gift subs. That is wonderful. We got a few first-time chatters on my stream. Maybe they're coming over from yours, but hey, McNets, Bridgewater, and a lot of good commentary about, like, being playful. I guess and Bobby Tables is saying that there are some industries where maybe playfulness is unwise. That's true. I don't know if I want playful...
Civil engineering actually is one of those. Structural engineering, they don't encourage a lot of playfulness there.
So, okay, before we get into the and I just want to acknowledge, I know that our audio is a little bit out of sync, and I do apologize for that. I think we're having a bit of an audio like a Wi-Fi weirdness thing, so apologies, but we're gonna soldier on. So, okay, let's talk a little bit about, just in general, at a high level, for folks who haven't seen your stream before. When we talk about these effects, what sorts of things are we talking about? Like, what's happening?
Yeah, so there's a lot of different ways that you can do effects on stream. Sort of at the highest level, there are a couple of plugin developers. There's a bunch of plugin developers for OBS, but there's two that really come to mind. There's a fellow by the name of Exceldro who's built a ton of amazing plugins. One of the ones that's sort of the gateway plugin to getting into this kind of crazy stuff is a plugin called Move Transition. And Move Transition will allow you to animate moving things around your screen. It allows you to animate moving, like, values. So if you have like an alpha value on yourself, you can animate it going from 0 to 1, so you fade in. It allows you to do really neat sort of keyframe animation kind of stuff on your stream. Additionally, he's been porting over an old shader filter, which is what we're going to be playing with in a little bit here, that allow you to do shaders, which are kind of visual effects you can apply to each frame of the video of a source that's coming out of the machine. So you've got really, really fine grained control. You can program it however you want to program it. You can do some absolutely incredible effects with shaders. Shaders are actually what all these big AAA games that are doing all their effects of things on fire and all that, a lot of those are from the shader stage of how a GPU renders things.
Right.
And so we're just going to harness that last stage and apply those effects to the video that's coming out of OBS.
Yeah.
So it's
this is something that you can I believe you were prepared for a quick sneak peek of the sort of thing we're going after.
Yeah, certainly. So and what I like to do is I like to tie my shaders up to redeems on my channel. So one of my redeems is Macintosh Classic. So someone redeems it, and now I look like, and this is probably going to absolutely kill our already almost dead bit rate, but I look like an old video on a Mac. I'm seeing it's extremely blurry here, but that's because of network issues. I think it looks a lot better in person. You should see my arm right now. It's pretty amazing. So.
Amazing. Yeah, 160p video.
So
yeah,
there we go. And then
we're rapidly approaching potato quality, but you know what? It's in the name of fun. So we shall potate and we shall learn.
Yes, okay. Absolutely.
So honestly, looking at what you just did, my first
Yep.
instinct is, well, I can't do that. So
Your first instinct was what?
my first instinct is like, I can't do that. How do I do that?
Oh, you easily can do that. You easily can do that. It's not rocket scientist kind of stuff. It's actually fairly straightforward. Today we're gonna walk you through two shaders. We're gonna
Okay.
write two different shaders. One is gonna be Jason's first baby shader, just a really simple shader where we're gonna learn a little bit about color channels and how we can kind of move things around in the canvas
Okay.
of the video. And the second shader we're gonna write is an ASCII shader. I've got to redeem. I won't do it now because it lasts for like 2.5 minutes and it alters my voice and stuff, but it basically turns you into ASCII art. And you can color the ASCII green or amber like a terminal, and it gives just a pretty cool effect. And it's a fairly complex shader built of a lot of simple parts. And so it's a really good example where we're going to kind of step through what are the simple parts and how we think about each of these steps. And once you kind of get that down pat, it's really not too difficult. The thing about shaders on GPUs, they can only do very, very simple math. So a lot of times the challenge is trying to take something that seems very complicated and simplify it. So the actual code when you see it isn't that crazy. We're not doing like huge linear algebra kind of things and that we're doing super simple math. So that's kind of if you got to go from complex to simple, which is that's a skill in and of itself, right? That
Sure.
can be a lot of a challenge too, but the actual programming itself isn't too difficult.
Yeah. I'm super excited to learn, and I'm also
Okay.
I'm very eager to try some things just in case things blow up. I want to see how far we can get before the whole stream self-destructs.
Yep.
So I'm going to take us over
Absolutely.
into pair programming mode, and everybody bear with me
Okay.
because we might have a little chaos while I get this scene set up, but let's try. Okay. I think that just worked.
That seemed pretty smooth.
Hey, look at that. Okay. So here's what I have. I have my this is can you explain what this is? Because you had me set this up beforehand, which was wise because it took a little bit of time.
Exactly. So what we're doing here, OBS can run as like it's your base app in Windows, or you can do a standalone install of OBS. And so what we did here, I talked to Jason last week, and we got a second version of OBS running as sort of standalone on his machine, which you can kind of think of as a sandbox. One of the things about shaders is that we're going to be taking code and we're going to be sending it straight to Jason's GPU. And you can imagine that if you mess that up, you can very easily crash OBS. And so early on when I was doing this kind of stuff on stream, I'd be making edits on my shaders directly on my stream, and we would see the blue screen with the guy with his head in his hands multiple times a stream because I crashed OBS, right? In this way, because we're using portable mode, we'll be able, if it crashes, the stream stays live, and then Jason just has to fire that version of OBS back up.
We shall see. The computer did just slip out a little note that was like, "Help me." Okay, so what I have here then is a mostly blank install of OBS. We did a couple things ahead of time just to make sure that it would work on my computer, but I actually kind of forgot what they all were. So it is as if
So we installed a couple of plugins. We installed the move values or the move transition plugin. So if we get to it, we can start to animate some things. And we also installed Exceldro's fork of the shader filter plugin, which is what will allow us to provide shader code to the GPU.
Okay.
So if you go ahead, if you just right click on scene, the blue highlighted scene, and just go down to filters, which should be towards the bottom there. And if you click the plus button, we just want to make sure that we see move action, move source, move value, and that we also see a user defined shader at the bottom. So we've got all of those. So we're good. We're
Okay.
good to go. I had sent you a link to a GitHub repo. Were you
Yes.
able to
Let me grab
grab that?
that.
So that's where we're going to put our code.
Okay.
And I don't know if you use WSL or WSL2. I would not recommend doing that here. I would make sure you grab the GitHub repo in Windows. Otherwise, otherwise OBS is going to have a hard time finding our shaders when the
Okay.
time comes.
I mean, to be completely
But we can.
honest, I don't do anything on Windows, so I don't know what any of what you
Oh,
just
okay.
said means, actually.
Okay, no worries. No worries then. Absolutely no worries. Why don't you just make a folder then on your desktop? We'll just do some copy paste stuff here. I think that's going to be the easiest. So make a new folder on your desktop and just call it like shaders.
Okay.
And do you have VS Code installed on this copy of Windows?
Visual Studio Code. Apparently, I do not. So this is going to be
Okay, well maybe we get
exciting.
that installed real quick.
Load not starting. Here's our download. Oh, thank you for cooperating, internet. See, did
Yes.
manage to crash my.
Yeah, this sort of work is not for the faint of heart when you're on stream. We've had some pretty humorous moments on my stream. There was a great one where someone clipped it where I just go, "Oh no, did I crash the stream?" And halfway through saying stream, the blue screen comes up. You know, it was like,
Okay, so we are extracting VS Code. When I had it, I don't know. It's
perfect.
probably somewhere. And now launching it. Okay. So
Yeah, and let's just open that directory in VS Code as like a workspace.
open folder. I'm going to desktop and I'm
Yes. Perfect.
trust.
I am the author, yeah. Okay, let's make a new file. And just call it like first shader dot shader. There we go.
Okay. All right. There we go.
Yep. And then what I would do is down at the bottom where you can select the language that the file recognizes, it should say something like Shader Lab.
It does.
Just type in HLSL. And then you're going to get some nice syntax highlighting because the shaders in OBS use a language called HLSL, which stands for High Level Shader Language.
Okay.
There's also apparently something called Shader Lab that uses something slightly different. So if you go back to the repo now, and there should be a first. Uh-oh.
Okay. Well,
I think I see it in the background there. There you go.
Okay. Back to
so if you click on View Code.
View Code.
And then just click on the first shader.shader file.
Okay.
And maybe click on raw or copy paste it. We're just going to paste that sample code in. This is just kind of a getting started. So this is the most basic shader you can have here.
Okay.
Go back to the GitHub repo and look at that README file. If you just click back on the LWJ shaders and click on the Exceldros shader filter fork link there.
Okay.
And if you scroll down, this is going to start to introduce these shader files, how things are installed. And if you scroll down a little bit further, keep going. The right here, the standard, oh, scroll up a little bit, the standard parameters. So these are all of the things that automatically get passed into your shader that you don't have to worry about. So
Okay.
image is the frame of the video that's currently being processed.
Okay.
Elapsed time is a time loop that you can grab how many seconds since the shader's been initiated, so you can kind of do animations and things.
Okay.
There's a lot of these different inputs that go along here. So I'll be talking about some of these as we type all this stuff in. So let's go back to our shader. And what we've got here, there's a main image function, and this is what the shader jumps into. The shader looks for main image,
Okay.
and it's going to pass the vertex data, which is basically your details about your frame and the current location that the GPU is processing right now.
Hmm.
And then you're going to return a float 4, which is just a vector of 4 floats, which represent R, G, B, and A for that pixel.
Okay. Okay.
Okay, so being a pixel shader, this shader modifies 1 pixel at a time. And you might look at that going, that seems really, really inefficient. But what you got to remember is there's like probably 7 or 8,000 pixel shader cores on your GPU. So what happens when a frame comes in, it just gets distributed to all these different cores, but those cores can't talk to each other. So all you know is your current pixel and what the whole frame is before any changes were made to it. You actually can't access what other pixels are doing with the shader, which
Right.
can get a little bit tricky in terms of how you want to think about things. So just something to keep in the back of your mind as we go through this, and I'll talk about some gotchas
And we
as
did.
as we
I'm going to bring up real quickly that we have done a little bit with shaders in the past, and we did that with
okay.
did it with Char style. I'm going to drop a link in
Okay.
the chat right now for anybody. This was like audio visualization based on like it was like a browser based shader kind of thing, and
Yep.
it had a similar kind of thing, right? Like the core concept being that I'm just going to repeat this back to make sure that I understand it correctly, and maybe to
Yep.
reinforce it for anybody who's hearing this for the first time. The way that a shader works is that it starts at the top left of your screen and it moves pixel by pixel, and you are able to like basically draw each pixel in a custom way, and then you have to use math basically. Like this is where I started seeing things that I hadn't seen since high school, like tangents, cosines, things like that. You can use that to and your current XY position on the screen to kind of determine where you are and make different pictures. So in the case of what Char does, she's listening for the audio and then creating like images that kind of react to the audio or to whatever whatever she's working on. And in our case, what we're going to try to do today is we're going to try to take various video inputs and modify them on the fly, which this is where it starts to get really wild to me, is knowing that once you've kind of learned this baseline of like, what is a shader and how can you manipulate something using shader code, it can apply to nothing. You can just draw cool things with it and do art. It can apply to literally any input, MIDI input, image input, audio input, video input. And then you can just kind of like, it can be real time, it can be recorded, it can be whatever you want. Like once you've learned shaders, you really do have kind of a superpower in terms of what you can do creatively on computers.
Absolutely. Well, I would challenge you to just change one little piece of your thinking on that. When
Okay.
you said that you start at the upper left corner and work your way across,
Yes.
in the case of GPU shaders, you don't know where you start or end because it's completely randomly distributed across the GPU. So one GPU core might be processing a pixel in the middle, one might be processing over on an edge. So there's no mapping back to, you can't like go look at what your neighbor's doing.
Right. You get no reference. Like you have no frame of reference. You're looking at one pixel at a time.
Correct.
And okay, so I thought that
Correct.
it like was
And
always scanning just because I thought that was
no, it's not sequential, which
got
actually
it, got
can
it, got
run
it.
into issues because if it was sequential, you could maybe peek back at the last pixel, but you can't do that, which makes certain things that you would want to do much, much more difficult.
Yeah, you're
or
operating in a
even
complete
impossible.
vacuum. Like each pixel needs to build its own
Exactly.
vision of the universe.
Exactly. Exactly. Which seems incredibly inefficient until you realize that you're getting your efficiency by throwing it at thousands and thousands of operating cores
Well,
to do this.
and we've
I mean,
got
that's part of what's so incredible about these GPUs.
well, and that's also why we're limited to simple math, right? Like you can basically do what, like
Exactly.
calculus, like that. Like you get
Yeah.
like
I mean, super simple stuff. Yeah.
yeah,
Yep. Algebra, basically. So
yes, exactly. I think that is
and yes, making up for it in volume. I think A. Bridgewater said make up for it in volume. Exactly. That's exactly what we're doing here.
Yes. Okay. So I understand the
So
core of what's
let's just-
happening. I'm going to repeat this
Yep,
back because it
let's just
happened a minute
parse
ago and
what-
I'm lost. Main image is the magic name for a function. And when you
It's
create
the
a
entry
shader,
point. Yep.
you need to create something called main image. That's like exporting default in JavaScript, node land or whatever, and it gives us
Correct.
the current pixel we're dealing with is what's passed in, and then we need to return. You said a vec4, which is 4 float numbers that represent
or a float 4
color and alpha, so RGBA.
Yes.
Got it.
Exactly. Exactly.
Okay.
So looking at this blind now. Well, I guess I put the I put the comment in as to what it was doing. I was going to say, look at this and tell me what you think it's doing. Essentially, image is one of those automatic inputs that our shader filter gives us, which is the current frame we're looking at. It has a function on it called sample, which means we're going to sample from image. There's this little thing called texture samplers. Samplers get kind of complicated. We won't really go over them, but just know that like a sampler, what it might do is if you don't land perfectly on a pixel, it might interpolate the color between 2 pixels, and you can define how to interpolate. Or if you go off the edge of your frame, do you want to pick back up at the bottom and continue? Do you want to use the topmost value that you just missed? Do you there's different ways you can clamp the edges of the image as well, which is what you define in the sampler. Texture sampler is just the most basic sampler that just says linear interpolate the pixel and clamp on the side. So if I tried to go to the point -1 for X, it would reset that back to 0. So you'd always get the edge pixel if you try to go off the edge. So we pass in our sampler, and then you'll notice we have this vin.uv. So vin is in what we call a normalized space. So we're not talking about pixels right now. We're talking about if we have our frame, left to right goes 0 to 1, top to bottom goes 0 to 1. So the values in UV are going to be between 0 and 1, where 0.5 would be the center of the image. So it's a relative mapping. It's not pixel by pixel.
Which is actually
now, almost
great because that means that I don't have to care about resolution. I just have to care about, I guess I have to think about things like aspect ratio, but I don't need to worry about like, oh, if I make this for a 720p and then later I upgrade my stream and now it's 1080, I don't have to go rewrite all my shader code because it's just using like the relative sizes.
Exactly. That said, it's going to cause us some difficulties later when we're trying to map a certain size to a certain size character for ASCII art, right? So we need a way to convert between. A lot of times we actually convert that UV coordinate to pixel coordinate. So that's the first code we're going to write here.
Got it.
What we're going to try to do here, we're going to just talk about colors and stuff. We're going to make a little plugin where we're going to have an offset value that as you increase that offset value, the red, the green, and the blue channels will move away from each other. So you'll get a real trippy like rainbow effect. You'll see how it comes together as we go through this. So the first thing you want to do, we're going to make a new float 2, which is going to be our coordinate. So you're going to type float 2, and it's a typed language. So for everything we specify, we have to say whether it's an int or a float 2 or whatever. And let's just call it coord, C-O-O-R-D. And we want to figure out what our coordinate is based on vin.uv. Okay. There's another input we've got called uv_size. And uv_size is 720 or 1280 by 720 or 1920 by 1080, whatever your actual pixel size is. So it's a float 2. And if we just multiply that by v_in.uv, it's gonna do element by element multiplication. So
because
if we're at 0.5,
then on a for easy math, 100 by 100 image, 0.5 multiply, you end up at 50/50, which is center.
Exactly.
Got it.
Exactly. Okay. Is shader a language, or is that what the language? So Robert, shaders are an operation that gets applied in a GPU to an image. The language we use to describe what shader operations we want to do is a language called HLSL, or high level shader language. There's also GLSL, and there's other ones as well. They all it gets complicated. Okay, so this chord will give you your XY coordinate on your frame. Let's define a float now, which is going to be our offset, how far we push the colors away. And we're going to think about this in pixel space. So let's just say 30 pixels.
Sorry, say that again.
We're going to think about this in pixel space. Okay. So let's just say that the offset is 30 pixels.
30 pixels.
Because 30 will tend to look good. Yeah, and you'll want to do a 0.0 or just a dot after it because it's a float. Yep. Okay, so now we want to figure out, given that we're in the center of the image, what we're saying is we want to sample maybe the red pixel 30 pixels over, the green 30 pixels the other way, and the blue maybe 30 pixels up. Right. So what we're going to do is we're in our location. We want to sample offset and then combine those pixels to what our overall output pixel is.
I see what we're doing. Okay. I don't know how to do it, but I know where you're headed.
So let's make the coordinates where we want to sample. So a coordinate is always going to be a float 2. So we'll make our first float 2, and let's call this one r_uv. So this will be our red, and we're going to convert it straight back into UV space, because remember, if you look down at the bottom, when we sample the image, we have to sample it in UV space. We can't sample it in pixel space.
Right.
So our UV, we're going to have, if we think about this a little bit, we're going to have our current coordinate. Let's say we're right in the middle, 50/50. And then let's just say our UV is going to be over in the X direction 50 pixels or 30 pixels, whatever our offset is.
Right.
So what would that be if you wanted to take your coordinate chord and add that offset to just the X?
So I remember having done this, but I have a hard time with the sets because I don't. Okay. This isn't a language I'm familiar with. So I know what we have to do is we basically need to create a new UV value that is like the X plus 30 and the Y. But I don't remember what the mechanics are that make that work.
Okay, so let's start. We're going to start with our coordinate, right? Because we know that that's our place of truth. So
Okay.
coord, and then we were going to add to it. But coordinate is a float too, so the only thing we can add to it is another float too.
Mm-hmm.
And so we can inline just say float 2 with parentheses, just like a constructor.
Oh, and then we do offset
And then
0, right?
comma 0. Exactly.
Okay. That
But
was
now,
I knew we were going to end up
because we're
somewhere like this.
yep. But now, because we've made this in pixel land,
Mm-hmm.
we want it in UV land. Now we have to go back and we have to divide by UV size. So wrap that whole thing in parentheses.
Okay. And I just
That
made this
whole
a float
calculation, yep.
because Farshid in the chat
Yep.
said it needed to be a float, and I believe.
Yes, good job, Farshid.
Okay.
And then after that, you're at the very end of that line, you're just going to divide by UV size, UV underscore size.
And that puts us back at our
And
0 to 1 value.
now that's giving us a point that we're going to sample our red channel from. And let's go ahead and copy that line and paste it twice. And then let's just do one for G.
B.
And for B. And for G, let's just set the X offset to negative offset.
Negative offset.
Because you want to go the other direction. And then for B, well, we would want to do 0. Yep, exactly. 0, comma. Excuse me. And yeah, I would do negative offset because your face is kind of towards the bottom of the panel, so we want to shift it up. Otherwise, it just looks a little bit funny.
Got you.
Okay, so now we've got our coordinates. Now we want to sample them all. So we're going to make 4 float 4s. One for our R sample, and I just call them R, G, and B.
Just call them R, G, and B. Okay.
I just call them out. Yeah, I would just call it R. And it's that image.sample that you see right down below. So you got your texture sampler, which is going to stay the same. And then, but you're, instead of sampling it from V in UV, exactly, you're going to sample it from your R UV value. Okay. And then you're going to do the same for your G.
B. Okay.
There we go. And so now we've got 3 different points sampled. Obviously, we don't want to return the original point. We want to return some combination of these, right? Mm-hmm. So in your return statement, instead of returning image.sample, we're going to make a new float 4. So delete the image.sample part. And then we got to pass it 4 values. So what do you think we're going to pass it for red? It's not quite going to be that.
Oh.
Because R is a float 4. We only want the red channel from our red sample. So we would just do
like the first channel, but I don't know how to get that.
Yep. So it's super easy because it's a color. It's just R.R.
Oh, look at that.
Yeah, it's really cool. And then .G and then .B. And then what I like to do for this particular look, I like to add the alpha channels of all 3 of them together and divide by 3. So you get like an average alpha from them. So just do parentheses.
Plus.
Yep. Hey, Exceldero, good to see you here.
A. And then. Oh my God. Okay.
3 point. Yep. Make sure you get the decimal in there.
All right. 3 point. I think I haven't. Okay.
Yeah.
So now what has happened is we have figured out. Okay. So we figured out what the actual size of our canvas is. We have decided that we're going to do an offset of 30. We grabbed our R values by looking at the not the current pixel, but we're moving over 30 and grabbing that value of red. And then doing the same thing with G and B in different directions. And then we use this, or sorry, we picked a point 30 pixels off. And then we use this image sampler, this texture sampler, to actually go and get the value of like how red is this pixel 30 points to the left. And
exactly
green and blue. And now we're rebuilding the pixel value that we're returning this float for by saying, give me the red channel from the red sample, the green channel from the green sample, the blue channel from the blue sample, and the average alpha of all.
Exactly.
Okay. I'm with you.
So and this is kind of this is like the process we go through when we build shaders. A lot of times it's get your coordinate system, sample the things you need to sample, transform them in some way, and then return the resulting color from that transformation.
Gotcha.
It's almost always that step-by-step process.
Got it.
So let's see if we did it right. Yeah. Let's go and save this file, obviously.
Okay. I have done.
And then we'll go back into OBS.
Okay.
And we add like, I think you're able to add like your video source or something to this.
Let's see how this goes. We're going to grab my camera.
Uh-oh. You know what? You can even grab that if you want, the OBS virtual
let's use
camera,
this one because this seems to be working. Yep. Kind of see what. Okay, so a little bit of
and then
inception, but
well, you don't. Yep, and then go ahead and right click on video, or even just click on video capture device, and then you can click the filters button above, which however you want to do it. And then we're going to add a new effect filter, user defined shader. And then you're going to use load shader from text file. Exactly. And then browse for that file.
Ooh, look at it. Look at it. We did it. Y'all. That's dope. And so there's so many cool, and like this is the sort of thing that's also really fun because from the little bit that I've been able to do with Shar in the past, I know that we could use time, for example, to make this kind of like shift a little as time goes on. Like we could say, you know, for every 30 seconds, I want you to, or every second, I guess, increase or decrease the pixel based on where we are. And then
not only that, but with move value, we're going to make one quick change to this in a minute that'll let you give a slider that you can slide that offset and set it.
Okay.
There's a great thing in move value where you can take your mic level output and use it to change a slider in your shader. So as you talk, you can have, you know, your head explode in rainbow colors. So let's go quickly back. We're gonna do an input for you quick because we're gonna need to know inputs in order to do the main show here, which we're gonna start in a minute.
Okay.
So go to the very top of your file.
Yes. Like
and
above.
Return down a few lines.
Okay.
So now you're going to make what's called a uniform float. If you put uniform out in front of something, it basically is saying we're going to use this as an input to the shader. And name it offset lowercase o.
Does it have a value?
And now with that, before you do your semicolon, you're going to do an open bracket, an open less than sign. Angle bracket,
we call them pointy
and then
boys.
Hit return. Pointy boys. There you go. Hit return, and then do a close one on the next line.
Okay.
And then set that equal to 30. So that'll be your default.
Okay. What can you explain what this is that we just did?
Well, we're going to put some settings in there. Settings in there.
Okay.
So these are called oh my gosh, my brain just went dead. They're not tags. They're I'll remember it later and you'll hear me just shout it out, but there's a specific term for what we're putting in these brackets. The first thing you're going to do is give the thing a label. So you're going to say string label equals, and then in quotes, offset, and maybe do it with a capital O so it looks pretty.
Okay.
And then you'll do a semicolon. And then the next line, you're going to do string. It's not generic C, Sean. It's a specific term for how OBS handles these things. This is going to be widget underscore type. And it'll be in quotes slider all the way lowercase. Annotations,
all the way
Exceldro. Yes, annotations.
Okay.
And then we're just going to set a minimum and a maximum. So you'll do a float minimum.
I assume is 0.
And set that equal to like, well, I would do it like minus 100.
Oh, I see. Oh, because then we can have
cross back the other direction.
Got it.
Yep. And then a maximum of 100. So these are putting bounds on what that field can do.
Okay.
And then finally, let's do a step size of 0.1. So you do float step.
Float step. You need a leading 0 in this, or you can
0.1. 0.1. I think 0.1 should work. And then get rid of your offset that's down in your main image function, because otherwise they're going to collide.
Can you set a default in here as well?
Well, you have set the default where you said offset after that.
Oh, this is the default.
Pointy boy,
Understand.
where you set it equal to 30. Yep.
Gotcha.
Yep.
I'm with you.
So go ahead and save that file.
I'm fighting against my Mac muscle memory here. I keep hitting.
I do it all the time too. And now go back to OBS.
Okay, back to OBS.
And now if you click on your video capture device and filters again, and then click on your user-defined shader. Now, if you scroll down, you might have to hit reload effect. And now scroll down. There you go. So now you can drag that.
Look at it go. This is amazing.
So it's just a super simple little deal. Yeah. So
Okay.
now you could use things like move value and things to have an animation of this. You could have it based on sound from a mic or an audio source. There's like a ton of stuff that you can do with this now, thanks to Exceldro's move transition plugin. It's just incredible. It lets me do so many awesome animation-y kind of things. So,
Yeah.
Okay. Well, I'm guessing what you really want to do here is turn yourself into Hacker Man, right? This is the goal. This is the goal. Let me see if I can. Oh, you know what? I might not be able to make this work. What do we want to do with Hacker Man? Let's kind of talk about what the effect kind of physically needs to do in order to give that ASCII art effect.
Yes.
So
really
ASCII
quickly,
art.
I forgot.
Yes.
I completely forgot. I was so excited to get started on the shaders. I forgot to tell everybody we've got captions and other goodies going on the site. So if you head over to lwj.dev, we have Rachel here with us today doing live captions. Because I'm on my other machine, the closed caption button isn't working today, but it is available on the stream here, and the captions will be available as they always are on the recording on the site. And that is made possible through the support of our sponsors, Netlify, NX, New Relic, and Pluralsight, all of whom are kicking in to make this show more accessible to more people, which I very, very much appreciate. Okay, I realized I forgot to do that, so I wanted to make sure I did that before I forgot.
Yep, no worries at all. No worries at all. Okay, so the idea behind ASCII art, if you look at especially like old school terminal fonts, there's a specific number of dots. You know, they were these monospace fonts that might be 8 pixels by 12 pixels. And there was a certain amount of that space that was filled with font and a certain amount of that space that was filled with white space. Mm-hmm. So something like a period took up very little of the space. So it was a very low density character. Whereas
Right.
like the @ sign takes up a ton of pixels. And so it's a much higher density kind of a character. So the idea behind ASCII art is to map the sort of apparent brightness of a pixel or a group of pixels
Mm.
to the density of a character and then replace it with that character. Right. So things like my hair that are dark might be like speckled with like periods, whereas
Mhm.
the shine on my forehead here might be a bunch of hashtags, and as that stuff
Right.
sort of comes together, you can get an idea of the shape that you're looking at. And we want to build a shader that's going to do all of this in real time, which
Mhm.
is which is going to be fun. So the first thing that we got to think about doing is like, how do we actually do that, right? The first thing that we want to do is we don't want to look at our individual pixels, because if we put a
Okay.
character in each individual pixel, you wouldn't be able to
Chaos.
tell, right? We want to take this down to much lower resolution. And so
Mhm.
we want to take our whole grid, like if you look at the box I'm in here, and think about splitting it into a grid that might be 20 by 20, right? If
Mhm.
this was square. And then we're going to kind of sample each of those 400 pixels, get a value for them, map them to a character and output that. Right? So that's the general idea. It's not, when you start thinking about ASCII art, it sounds so difficult, but when you actually look at what it's doing, it's really not that difficult of a process
It
thought wise,
yeah,
right?
the idea is straightforward. The execution
Hmm.
is probably straightforward once you've done it once, but is kind of mystifying
Exactly.
because, like, okay, I know what we need to do, right? Like, we're going to build a grid. We know that the grid is going to be, say, if it's a
Yep.
monospace font, I don't know, 10 by 10 pixels, and then we need to grab
Yep.
groups of
Yep.
10 by 10 pixels and like get the average brightness of those and then figure out a character map and all these
Ex-
different things, right? So I understand it, and then
exactly.
I start thinking about doing it. I'm like, whoa, just full like cross-eyed, no idea. Like
Yep. Yep. Well, we're gonna get you there, because it turns out it doesn't take much more than what we've already done.
oh, excellent.
The hard parts are behind you. So um so let's go and make a new file in Visual Studio Code here.
Okay.
And we're just going to call this one ASCII.shader.
Okay.
And again, you're going to want to switch it to HLSL so that the syntax highlighting looks okay.
Okay. HL here. There. HL. Okay. I need.
And then why don't you just copy your first shader and just paste it in, because we're actually going to make some inputs right away, and we'll delete out everything that's inside of the main image function to start. But leave your you'll need your open curly boy there.
Early
There you
boy.
go.
Okay.
And yeah, okay. And leave the offset for right now, because we're gonna make a few of these.
Okay.
Um, let's rename your offset one to be scale. So we're gonna have some sort of a scaling factor that we're gonna use. And actually, why don't you leave it as a capital? I tend for my inputs to have them capitalized, just so that I know that they're inputs.
Okay.
I only did the offset lowercase because that's what we'd already written before.
Oh, I got you.
And then the minimum on that, let's set the minimum to 0.1 and the maximum to 20.
Okay.
And then we'll do a step size of 0.1, and we'll set the default to 1. Okay. And so the one thing we got to consider here is HLSL, your GPU cores, they know nothing about fonts. Fonts, they just don't exist in this world. So what we're going to use in that GitHub repo I gave you some images where we're going to sample characters from those images. So if you go take a look at textures, yep, And if you just click on one of them, I think they'll give you a preview of it. And yeah, you can see how they get denser as we go along. So what we're going to do is we're going to sample from some point along that spectrum to grab the pixels that we'll use for that font. And you'll probably want to grab both of them because they both do give pretty different looks.
Okay. So I'm gonna put the into the shaders.
Yeah, you can just put it in shaders, just somewhere where you can access them.
Okay, let's get. Okay.
There you go. Okay. So one of the things that we need to know in order to do this sampling is like how many characters wide is my image file? Like how many do I have across? How many pixels wide is the image file? Because that tells me where I sample and what size I need to sample a character.
Okay.
So we're going to make a few integer based inputs. So if you go ahead and copy the scale one, no, the uniform.
Oh, inputs.
Uniform inputs that. Yep, because we're going to want to be able to specify those. So copy that.
Whoa.
And no, you're good. And then I would just do it above. Well, yeah, you could do it below scale. So do 3 of them.
Okay.
And make them integers. And the first one here, we'll call this font texture height. Oh, sorry. The first one we'll do width, then height. So width? Capital F for font.
Oh,
I would do font texture width.
Texture width.
Yep. And then give it a nice label. And then unfortunately, your minimums, maximums, and stuff are going to have to change to integers.
Okay.
There we go. And then a minimum on that might be 1 pixel, and then a maximum might be like 2,000 pixels if you had like a ton of characters that you were using. And then the step size will just do 1, which I guess is default. So I guess we don't have to do 1. And then just do a default of like 120.
Okay.
Because a lot of times fonts are 12 characters, 12 pixels wide, and you have 10 of them. So the next one we'll do. Yeah. Good idea.
Okay.
Then we'll do font texture height. And then make that one go from like 1 to 500. And then maybe set the default to 10. And then finally, we're going to do the font texture num chars, like the number of characters that we have in the texture. Okay, and then I would set that ranging from like 2 to 256. You got to have at least 2, otherwise you don't have any difference in color. And then maybe set the default to 12. There was an old file I was using that was 10 pixels by 120 pixels and had 12 characters in it. So that's why the defaults are what they are.
Okay.
So we're not going to use these quite yet, but well, actually, we're going to use them pretty much right off the bat, some of them. So now let's go down into our main image. And again, one of the first things we always do is grab our coordinate. So that's that
float 2 chord equals it was v in dot uv divided by no that's not right, times you're gonna have to remind me what the
it's uv underscore size.
Oh, I'm already out of place.
No, you were right. That was times
uv
right.
I was right. Okay,
you can do it that way too. Yeah.
uv underscore size. Okay.
Yep.
Okay,
so that's going to give you your current coordinate. We're going to be using that a little bit later. Now we want to take our character height and convert it to a float, because right now it's an integer because the image has an integer number of pixels, but we're going to be doing everything in float math. So let's make something called char height.
And that.
And it's just float. And then in parentheses, you're going to pass it in font, texture, height.
Okay. And I'm going to assume that I do this again.
And then we're going to do, well, we're going to also make a character width, but we don't want the whole texture width. We want the character width, because that's going to tell us how wide things are. So we got to do just a little bit of simple math. It's
so,
like,
so this one is going to be
6th grade math.
the width divided by the character, the number of characters.
Exactly. Okay. But you got to convert them both to floats.
Floats first
when you do it. And you're off the bottom of the screen a little bit with the code. Just FYI.
Let me bring that up. And then it's float font number. That?
There you go. Yep. So that's going to give you the width of one of your characters.
Okay.
And now what the scaling factor I put in here for, this is planning for the future. Just because your font file has like 10 pixel by 10 pixel characters doesn't mean that's the resolution that you necessarily want it to display as. You might want them to be 20 pixels by 20 pixels because you want it to be super chunky. Or you might want it to be 5 pixels by 5 pixels. And so this scaling character, their scaling value is going to let us just change that scale regardless of what our font resolution is.
Okay.
So that float up there at the top. So we're going to do a quick calculation of what our grid size is going to be, which is now going to be based on our character height and width and scaling factor. So let's make a float 2.
Yeah, see, I'm getting this.
Because it's going to be the X. Yeah, you are.
And you wanted to call this grid
and we'll
size?
Call it grid. I just call it grid.
Okay. And now this one is
so then we're going to make
be float 2, and I'm going to take the char height times the scale.
I would start with width.
Oh, right. Because X, yeah, okay. So take my width.
Yep. So XY kind of a.
And then I'm going to take my scale, because that's already a float.
Exactly.
Okay. And then I can do the same thing for the height times scale, and that's the grid.
Perfect.
Okay.
So now we want to get a UV coordinate that we're going to sample. So just imagine if my frame here was a 3x3, right? So we had a vertical column right here. The grid is telling you the width of each of these blocks, 1/3 of the screen. So what we need to do is we need to say we want to sample not at the grid lines, but halfway between 2 grid lines. Right? So if there's if imagine again 3x3 and my head is basically the middle block. I'm doing a little Madonna dance here, right? The point, yeah. And Vogue, exactly. The point we want to sample isn't like this upper corner here. The point we'd want to sample would be like the center of my nose, which is in the middle of the box.
Okay. I understand. I thought you were talking about taking the average of.
Now you got it. Okay.
Yeah, I'm with you. Okay.
Yeah, no, it's simpler. It's way simpler. So we want to pick out what that UV sampling point is now. So let's make a new float 2 and call it UV. We'll set that equal to a float 2. And this one's got a little bit of a calculation to it. So do float 2 in a parenthesis. Now hit return because we're going to do each on its own line. You can break it up by 2 lines like that. Okay. So we're going to go back and we're going to do like the equivalent of like modulus math a little bit here, which I know is totally painful, but it'll end up not being too hard. So the idea here is in our X value, right? We want to take our coordinate for X and we want to divide it by our grid X, which will give us like how many grid points over we are. Does that kind of make sense?
Right. And this is, am I doing this correctly?
Exactly.
Okay.
But we don't want a value of like 3.6 grid points over. We just want to know that we're at grid point 3. So we want to floor that value.
Okay, and we do that in the same way that I would do it in JavaScript with like these.
Exactly. You just wrap that in a floor.
Okay.
And now, because we know that we're 3 grid points over, the next step is to how big is a grid point?
So we need the UV size divided by the grid.
It's simpler. It's just times grid.x.
Oh, times grid.x.
It looks like we're dividing by grid and then multiplying by grid, which should just give us back that coordinate. But because we're flooring that first part of the calculation, that'll move us from like partially over on my forehead here to the start of the grid point here. And now we got to add half of the character width back in to get us back to the center.
Okay. And I do that with char width divided by 2.
Yep.
Oh, this line. And it's a float.
Yep. And it's a comma because we're in a constructor. And then we're going to do the exact same for y.
Okay. And this one we do the char, or we do y. And then height. Right?
And are you adding grid.x times character width there? Or is that a multiply? I can't. It's a little fuzzy on my screen.
This is a
After
multiply. Let me make this a little.
Okay, it's got to be a plus because you're adding because you're just shifting over by that amount.
This is a plus?
Yes. Yep, okay. Because we got our start of grid point and now we're adding half of a grid block to it.
Wait.
But then the grid.
On, I'm wrong.
Oh no! I'm sorry. You're right. The other one is I'm a character off. That is a multiply, and the next one is a plus. Apologies.
Okay, great. No, that's good. Is this big enough to be clear now?
Yes, it is. It is. Looks much better. But now this is all in coordinate space, and we want to get it in normalized space. So we just divide it by UV underscore size.
And we do all of that here?
Yep. Okay. We divide the whole float.
And now we're back to that we could return
0 to 1 value across our whole frame.
Okay. And so then
so now let's just
this.
Exactly.
Okay.
So let's see how this works. How would you expect this to look before we apply it? How would you expect this to look?
Because we're not actually using the images yet, I expect this to look like absolute chaos. Because my guess is that we're gonna kind of mosaic the image here by pulling weird samples from weird points.
Okay. Well, let's see how it looks.
Okay. All right. So I'm going in. And should I do a new scene for this or just like turn one off?
I would just go on that and then go to filters, and then you can actually just change the filter that one is loading. So if you click on user defined shader and then browse to your new shader file.
Shaders, load.
And are you getting anything? You're probably not, because we probably have an error. So now we get to learn how to debug. So unfortunately, debugging can be a little bit of a pain in the rear. If you go back to OBS, and you go up to help, in the help menu, there's a show under log files. You want to show log files, and then double click the bottom one there. And then open it in Notepad. That's fine. And then scroll all the way to the bottom. Oh.
Missing pixel.
And let's see. Unable to. Yeah, if we drag that out a little bit here. Let's see, what is that saying? Effects
Redefinition
from
of
parser.
saying I'm doing a redefinition of care height.
Okay, so you must have 2 care heights in there somewhere. So,
oh, look what I've done.
Yep, there you go.
Okay, well, in good news. Good. Try again. Filters. Here.
Yep.
Reloading.
And we're still not quite there. There's probably something else. And then you actually have to close that text file down and reload it again.
Okay. And I'm gonna.
Yeah, sometimes code, it's not too hard to figure out. Other times, the debugging process through log files can be a major pain. Sometimes it just does not want to agree with you.
Missing pixel shader, unexpected token. Okay, so
Yeah,
I
it would
have an
be
unexpected token somewhere. I have an extra closing round boy. So look around in here for a second. $9.43 end.
Oh yeah, you got another comma. You've got an extra comma there.
Can't. Oh, you can't do that.
No, it's like C.
These are my bad.
I do
JavaScript
it all the time
because
I live in. Yep. I do the same thing. Plus, I do a lot of Python, and that's always, best practice in Python to leave your trailing commas. Oh, and now scroll down. Look,
we pixelate.
Yeah.
Okay, I understand.
We pixelate.
So that makes sense because we are simplifying our image by basically replacing all of the images or all of the stuff in the grid is being replaced with that one pixel because we're averaging, like we're going to the grid, we're figuring out the center pixel, we're then using that center pixel for every pixel in the grid.
Exactly.
Cool. Okay,
exactly.
So we have now figured out how to do
you've got a
like an anonymizer
pixelate shader.
Yeah.
Yeah, exactly. And if you go to the filter screen again, and you click on user defined shader, you should now be able to scroll down and grab that scale and you can drag it big, you can drag it small, and again, you could use Exceldro's stuff to animate it as you change scenes. There's all sorts of stuff that you can do with that now. I have some effects. I actually do this with hexagons on my stream, where it doesn't convert it to like a square grid space. It converts it to a hexagonal grid space. And that's my secrets coverage. When something might be up that I don't want people to see, it wipes hexagons across the screen for me.
Oh, cool.
That are showing the pixels through, but in this way that it's anonymized.
Yeah, and there is a note in the chat that AI is actually really good at depixelating things these days.
Though the one thing that we found, which is what I tend to do, I never show anything too sensitive on screen, but if you make sure your pixel size is more than 2 lines of text tall, it can't. There's not enough information because it doesn't know where a line ends and where a line begins, and you'd be covering like 10 or 12 characters per block, and there's just no way to infer from the density what characters they might be.
Yeah, and it is kind of
a point.
It's kind of hard to imagine what, like, maybe it's possible with AI to decode what this says, but that seems pretty unlikely because of how small, like, the don't appear to be something that would actually to depixelate. But blur is easier for AI than pixelation. It has to be okay, cool. So definitely some things to consider there if you do decide to use this. My preference is to have a second monitor, and I just put all the secret stuff over on the second monitor because I have been bitten before.
Well, don't ask me about the time that I was actually showing my lat and long coordinate of my home office
Oh,
for
jeez.
2 hours on a stream in a log that kept going by. We were working on a telemetry data thing for my ski streams,
Oh, jeez.
and I didn't realize I was literally broadcasting my location to the world for 2 hours.
Yeah, I think at some point I've thrown my phone number up. I've like thrown
Yeah,
up
yeah,
API keys to really expensive stuff, so I had to like panic roll those and
yep. Okay, so let's move on to the next step.
yes.
The first thing we want to do is, rather than just returning that image.sample, let's pull that out as a variable, because we're going to have to do some stuff with that color sample that we get.
Okay, so this is going
So
to
just
be
say
a float
for call. Oop. And I would call it COL for color equals there.
Okay.
And then you can add a return call for now, so that OBS, doesn't complain. Holy cow, the Primogen is coming in.
Hello, Primogen friends. We are in the middle of writing some shaders for OBS. So where we've gotten so far is we're actually kind of coming close to the end here, but we have let me get this filter up. We've built this one that does colors here. And so this one you can color shift the output to get some cool effects like this. And we are currently working on we want to do like a hacker mode with ASCII shape. So we have figured out how to pixelate. We're sampling we've broken the screen up into a grid, and then we are using some math. Let me pull up the math while we this. We're using the math to then figure out like our grid size, centralizing or figuring out the center point of each grid, and then replacing all of the pixels in that grid with that one point that we've sampled, which gives us this kind of pixelated feel. And now our next step, which we have to try to pull off in about 5 to 10 minutes, is to get the ASCII text into this image, or into the place of these pixel box that we've made.
Okay, let's do it.
All right, here we go.
Okay, so the first thing we need, we don't want to convert these pixels in terms of color. Remember, I talked about the pixel density relates to sort of the brightness of the pixels. So we need to grab the luminance of those pixels. So let's go up above, and we're going to write a new function. And we're just going to call it up above our main image. Yep.
Okay.
And we're going to write, it's going to be float space. And then we're going to call the function, I just called it gray, Gray, for kind of the gray value of it. And its input is going to be a float 3.
Okay. And you're going to have to remind me. I don't remember what function syntax looks like.
You're getting it. You're getting it perfect. Okay. And it's going to be COL for color, some color we're going to pass in.
Okay.
And then open curly boy and a close curly boy.
Open curly boy, close curly boy.
Okay, and we're just going to do the standard RGB to luminance calculation. We're going to return.
Okay.
And it's going to be call.r times 0.299 magic numbers.
Okay.
Plus call.g times 0.587.
0.587.
Plus call.b times 0.114.
0.114. And now this is just like somebody figured out how to determine the brightness.
Yeah, it's been used since like the beginning of computer graphics as a conversion from RGB to luminance.
Okay.
So and then real quick, what we can do is in your return. Oh, actually, first we have to call that function. Okay. So just say float g.
Float g equals
gray
of our.
And then you're going to feed in call dot RGB, because we didn't have it send the alpha channel.
Right, because we don't need the alpha channel. Got it.
Yep. And then just return. We'll make sure this worked right. Float 4. And it's going to be GGG G, comma, G, comma, G.
Oh, okay, I'm with you. G.
Comma, call.a, just to grab that alpha value.
Okay.
There you go. And then save it, and let's just make sure we should be basically be getting what we got before, but it should be black and white if we did it right.
Reload. Now we're black
There you
and
go.
white. Okay.
Okay, now we're black and white. Okay, so now on to the fun part. The next thing we need to do, we need to locate the character that corresponds to our luminosity, so
Okay.
that the lighter pixels get the lighter characters and the darker pixels get the darker characters.
Okay.
So under your float G, let's add a. Yep, and those are the images that we're going to use.
Yeah, I just wanted to show for everybody who's joined since we talked about this, we're going to be using these as our like light to dark character sets. We'll see if we actually have time to get through. We can't go too much over over time.
No, we got 5 lines of code to write.
Right, let's roll.
So let's go through it. Right after, wrong one. You're going to go to your ASCII shader. Right after your float G line there.
Okay.
We're going to make a float character UV, CHR-UV.
Oh, character. Like,
yeah, and then a capital U and then a lowercase v is fine.
Got it.
And that is going to equal, and it's just going to be some magic math here. It's going to be floor G times float. Font texture num chars.
And that's our input from up here for anybody who has not seen that.
Yep. And then that is going to be divided by, hold on, where are we dividing? The floored bit is what's going to be divided. So outside of the floor. There you go. Float font texture num chars. So it's similar to what we did with the grid, only we're selecting how many grid points over our character is going to be grabbed.
Okay. Yeah. So this is letting us, no matter where we are, we're locking to the start point of one of our characters.
Yes, exactly.
Okay.
Based on its G value, its grayscale value. Okay, we're going to make a new float 2 now. And we're going to call this sub POS, like sub position.
Got it. And
that is going to be float 2. And the first value is going to be frac. It's a function called frac, F-R-A-C.
Okay.
And then in parentheses, it'll be quard x over grid x. And then the y is going to be frac quard y over grid y. And so that's the fractional component. Like if we're at grid point 2.3, that'll give us back the 0.3.
Okay.
Okay, next line. Oh God, I hope these work. Float 2. And this will be our sample UV. So this is actually going to be our sampling point for our character. And that's going to be, this one's the complicated one. It's going to be float 2.
Okay.
Char UV, comma 0.0. So we're using that X coordinate and 0.
Got it.
Plus, and it's going to be another float 2. And we'll do 1.0 over float font texture num chars, comma 1.0. I can explain what all these mean to you off stream. And then that after that parenthesis, we're going to multiply that by sub position.
Okay.
Okay. And then now we got to go up to the top.
To the top.
And we got to add another input, which is going to be for our font texture. So go to the very, very top.
Very, very top.
It's going to be a simple one, so you don't want to do a copy paste in this case.
Uniform.
It's going to be a uniform, and call it texture 2D, all lowercase is the type. And then it's going to be called font texture, capital F, capital T. And then we have our pointy boys.
Pointy boys.
And the string label equals font texture.
Okay.
and then do a semicolon at the end of the pointy boy. Yep, there's no default. Okay, now scroll down to the bottom. Now we just got to sample that thing.
Okay.
So we're going to say our float for character, CHA, call it CHA. Or, yeah, I guess you could, yeah. Equals font texture dot sample. It's got to be a capital S on the sample. Right. Yep. And then texture sampler.
And the sample UV.
And we're going to sample UV. Yep. And then just return CHA. And this will be your most basic. I had another step if we were going to get to it where we could change color and a bunch of that, but this should do the trick if we... All
right, everybody cross your fingers because I think we got to be done whether or not this worked.
No, yeah, it worked. So click browse for font texture.
Browse for font. Oh, font texture. Browse.
Yep. And then grab one of those.
Okay.
Okay, and then if you scroll down, the font texture width on this is 1260 because now it's not sampling it from the right spot.
All right, 1260.
It's 36 pixels high.
6.
And it's got 70 characters. And you can, I don't know if we can, yeah, you can start to see it.
Yeah, if I make it really small.
Yep.
Right. And so this is definitely something that would work better if it was a video input. Let me see if I can switch this really quickly to just my camera. My camera doesn't want to. I'm using it in multiple places right now. So I think I might hit the limit how many it's. But you can see that it is. You can like follow the mouse around here. You can see that it is doing things as I kind of mouse over buttons. The texture is changing. This is really cool. So
it's a lot of fun.
This is awesome. So I love this. Like this is so much fun. I feel like we have been able to do so much more than I thought we would have pulled off in 90 minutes. We are, however, out of time. So I want to throw everyone to your GitHub repo. So I have that. Oh, I'm working across multiple. But in the chat, and then I'm also going to shout out to your so everybody who's here, if you want to see more of this, this is what Mark does. Finite Singularities channel is very much like tons and tons of fun things like this and a lot more. Mark, where else should people go if they want to learn more about this, learn more about you?
You know, in terms of learning more about me, it's pretty much I mean, you can go to my Twitter, which is it's even spelled wrong. If you just search for me on Twitter or go to I think I got the link in my page right there. It's finite singular or like RTY at the end. I tweet from time to time. Someone can pop that in chat if they happen to have it. That'd be great. Probably my stream is where I'm most present. The other thing I would say, if you want to play around with shaders, there is a website called Shader Toy, which has all sorts of they're those GL or HLGL shaders, which are a whole lot of fun to play with. You need to change the syntax a little bit to get them to work in OBS, but reach out to me. I'm happy to help you with kind of figuring out how to change it. It's not too difficult, but I've learned a lot about effects and things by looking at what people have done on Shader Toy, because there's all sorts of awesome devs over there that make some really cool stuff. So if you want to learn more about the shader stuff, I would definitely head over there. But thank you so much for having me on.
Yeah,
I've been looking forward to this, and it was an absolute blast.
Yes, it was so much fun. I'm so glad you were here. I cannot wait to continue digging into this. So everyone, this show, like every show, was closed captioned. We had Rachel from White Coat Captioning here today, and that's made possible through the support of our sponsors, Netlify, NX, New Relic, and Pluralsight, all kicking in to make this show more accessible to more people. While you're checking out things on the site, make sure you go and take a look at what's coming up on the stream. We've got so much good stuff coming. We're going to be talking about API development. We're going to be talking about databases. We're going to be talking about testing. We've got so many good things coming. So do the follow, do the like and subscribe, do all the things that you want to do. But come back and hang out with us again. With that, I think we are significantly over time. So thank you, Rachel, for staying a little bit late.
Sorry.
And we will see you all next time.